All right, everybody, welcome back. We are going to be dealing with functions today. So let's take a look at what we're dealing with. Let's see, y equals mx plus b on number 2. Looks like we just have to analyze a graph, choose order of pair. So another y equals mx plus b, y equals mx plus b, y equals mx plus b. A table, rate of change, so that's your slope. Okay, all right, another y equals mx plus b. And if you're like, what are you talking about? Y equals mx plus b. All right, y equals mx plus b. Remember I said my favorite equation of all time. So that's what we're dealing with. And all the way to number 15. So a couple graphs, some tables. Okay, I can already tell which one of these is a function. So input and outputs. All right, not that horrible. And we get to use our calculator for the whole quiz. So when we need it, we'll use it. All right. So the graph below shows how much money Mr. Beltran has spent on his 2 doggies over the last 10 years. Oh, Bella and Ariel. So expensive sometimes. Oh, yeah. Okay. Read each statement below about the graph and determine if it's true or false. So the amount of money spent increased between years 6 and 10. So years 6 through 10. So from here all the way to here, does it go up? Yes, it does. All right, the amount of money spent decreased from 0 to 4. So from 0 to 4, it went up, then it went down, so that's false. And then no money was spent during 4 and 6. So 4 and 6, what happened? Is that true? So remember, money spent. So on year 4, I actually spent $2,000. Year 5, I spent $2,000. Year 6, $2,000. So that's false. So that's like a trick one, right? Because you're like, it's flat, so it's not going up or down, so it has to be 0. No. That just means it didn't increase, okay, or decrease. I still spent $2,000 between 4 and 6, though. All right, number 2, the choose a graph represented by the linear function in the graph below, or choose the equation. So why was I saying this is my favorite? Because it's used so often in a bunch of different ways. But the graph is my easiest and my favorite to identify because the b is on the y-axis. It is your y-intercept. You get it? Your slope-intercept form. That's what this is called. So that is your slope, and that is your intercept, a.k.a. the y-intercept. That's why I said it's on the y. So where's my b? My b is -3. Yeah. Okay, that didn't help. So what's my slope? My slope is rise over run. So let's pick 2 lattice points. So that one and that one. And it looks like I got 3 over 1. So my m equals rise over run, which is just 3. And it can't be negative. It can't be a third. So my answer is A. So this one's pretty chill, okay? All right, choose all order pairs that are on the line. Okay. So here's where it's a little tricky, and it just, a lot of this is just plug it in, all right? I'm going to show you why the calculator is really nice because remember, one of the things I always tell students is if you're solving an equation and it's multiple choice, they gave you the answer so you can just plug it in, okay? This one, technically, they gave you the answer for x and y as a pair, right? So if my equation is y equals -x plus 5, well, y is already by itself, so 3. So you just got to plug in the x, so negative parentheses plus 5. And in that parentheses, I'm going to plug in 2. I'm going to plug in 0, 4, and 1 and see if I get the output. So if you'll notice, that's my input, that's my output. So if I plug in 2, I get -2 plus 5, which equals 3. Is that what I wanted? Is y equal 3? Yes. So that's all we're doing, okay? But the beautiful thing about it is we got a calculator to make our lives a lot easier. So let's take that out. And here's what I'm talking about. I'm going to clear that. I don't have to put y. I just have to put this right here. So negative x, where's my negative? There it is, plus 5. So let's start at the beginning. My first one was a 2. Did that give me 3? Yes. Then I'm going to go delete the 2. See how easy it's going to be? Delete the 2. And now I plug in 0. So put in a 0. That gave me 5. Is that what I got? Yes. Now delete that. I'm sorry. And then I'm going to plug in a 4. The 4 gave me a 1. It is not 9. It is 1. So that one is correct. So the one that didn't work out was the 4, 9. But you see, right, the calculator is so much nicer because I don't have to retype this over and over. I can just plug in X and then check your Y, right? What did you get? That's your output. All right, so let's close that. Liam claims that the equation y equals 4x minus 6 is a linear function. When I say line, it's a line. It goes like that, it goes like that, it goes like that. Okay, it's just a straight line. Which statement supports Liam's claim? The function has no exponent higher than 1. That is true. Okay, so your exponent goes on top of a letter, so it's right here. The function is not a straight line. That's false. It is. It is a straight line. The function is a parabola. No, if you forgot a parabola, parabola is like a U. Okay. The coefficient of x squared is a 4. What x squared? There is no x squared. So that one's not true. That doesn't matter. Okay. So this one was only one option. And again, I wrote this test. So usually when it's check all, you should have picked 2 or 3. Right, I think this one I should have erased is a straight line. So then that one should have been true. Okay. So let me fix it on my end over here since I have it open on my computer. All right. Okay, number 5, Liz is shown the graph below and says that the equation is y equals 2/3 x plus 3. Why is Liz wrong? Okay, so Liz is wrong. Let's look at our options. And if I look at my options, it says blah, blah, blah. Okay, that's a lot of reading, guys. But what I notice is the correct equation, the correct equation, the correct equation, and all they cared about was this one. Is it that? Is it that? Is it that one? Or is it that one? So notice, this is basically number 2. Like, this is the same question. They gave me a graph, and they want me to pick the correct equation. They just reworded it super wordy and long, right? Trying to be annoying. But it's the same thing. A, B, C, D, they're all different. And I just got to pick the correct one. So let's see which one it is. So again, y equals mx plus b. Here's my b where it crosses the y-axis, my y-intercept. So it should be plus 3. So that one is plus 0. So it can't be A. That one is plus 3. That one is plus 3. That one is 2/3. So it can't be that one. So now it's a 50-50. So how do I find the slope? Now think about it. This one is going negative. That means it's going down. This one is positive, which means it's going up. So my answer should be C. And just to confirm, let's check. There's my next point. And if I do rise over run, my m equals 3/2. Okay. All right, next one. To help customers figure out the cost of number of items that they are purchasing, a vendor placed a poster on the table that shows how much they would pay for a certain number of items they purchased. Excuse me. All right. Enter the rate of change. So rate of change of the cost in dollars per item. So again, if you've seen my other videos, anytime you see the word per, that's your slope. That's your rate. That's your slope. Okay? And normally your slope is rise over run, right? But think about it. If you're rising, you're going up or down. If you're running, you're going left or right. And if I have a graph, I go up or down on the y, and I go left or right on my x. So the thing is, we call it delta y over delta x, which is a fancy way of saying the change. How did it change in the y direction? So if you think about it, this is an xy table. So how did it change going from here to here? And how did it change going from there to there? The other way we can think about it, right, which you should have learned, hopefully, is that to find the slope it's y2 minus y1 over x2 minus x1. And if you think about the language change, it's the difference. You get it? You just got to subtract them. So normally you can just say, oh, these are pairs, right? So this is technically 5 comma 13, and I have 11 comma 28.6. So now if I look at this, this is my x1, y1, x2, y2, okay? So again, I'm going over this a little bit more explanation, right? Just so you could see visually how you could do this. So if I were to use this right here, I just substitute. So 28.6 minus 13 over 11 minus 5. And that's where I have my awesome calculator. So let's clear it. I got 28.6 minus 13 over 11 minus 5. And my answer is going to be 2.6. All right, so if you wanted to do this on the table, we could say, how did it change from 13 to 20.6? Well, isn't that just subtracting, right? 28.6 minus 13, that was plus 15.6. How did it change from 5 to 11? That's plus 6. And because it is y over x, here's your delta y, here's your change in x. And if I put 15 over 6 divided by 6, guess what? I get 2.6. It's the same thing. So those are all different ways you could have done this. Okay. Hopefully one of these makes sense to you. If they all make sense, damn, good job. All right. But figure out which one it is, rewind, okay, and kind of rewatch this if you want, a few times if you have to. All right. Okay, because a lot of these are like the same. Okay. And I'm going to usually just do the subtraction. Okay, I'm usually going to do this. All right. Okay. Mr. Vedran loves to cook Thai food at home and recently bought a large bottle of Healthy Boy brand soy sauce because they're all different. Okay, not all soy sauces are the same. This is specifically from Thailand. Okay, because it's Thai food. Below, you can see a table that shows the relationship between the number of dishes he can cook and the amount of soy sauce left in the bottle. So I'm trying to think of what happened. So dishes cooked, 34 ounces left. This doesn't make sense. That does not make sense at all. Which equation shows the ounces left y after the number of dishes you cook? So essentially, it's y equals mx plus b. So the idea is which one of these is where, okay? So let's think about this. When I say y equals mx plus b, that is your y-intercept when x equals 0. So if this is x and that's y, when x equals 0, what is it? Well, think about it. This is going by ones, right? This one is going by, and you'll see why I was like, that doesn't make sense. I did it backwards. So 34.6, nope, I got to do it the other way. 37 minus 34.6. That's plus 2.4. Is this the same pattern every time? Let's check. 39.4 minus 37. Yeah, that's plus 2.4. So if I need to find my b, right, what is it when it's 0? I got to go backwards. So I'm going to have 34.6 and I'm going to subtract 2.4. So I'm going to subtract 2.4 and that gives me 32.2. Is that one of my options? No, it wasn't. That's what I'm saying. I screwed up. Okay. So in this case, I should add y equals mx plus b, y equals mx, and then my b was 32.2. So now how do I find my m? My m is my slope. Your slope or your rate more specifically your unit rate. So for every one that's a unit, what did you move? 2.4. Now here's where I told you in another video, you're like, wait, there's fractions. So notice the only fraction there is 12 divided by 5. So 12 divided by 5 is 2.4. Look at that. So y equals 12 divided by 5x plus 32.2. And again, I wrote this wrong. So in this case, it was increasing, so it wasn't going down. It wasn't for x. And the answer should have been not 36. It should have been B, assuming it was 32.2. So I'm going to fix that. I know. I'm sorry. It happens if you've seen other videos. All right. So 32.2. Okay. So that's the correct one. And again, on versions 1 and 2, they're actually done fine. Okay, it should be okay the way they got worked out. This one, if you think about it, it doesn't make sense, and just a heads up, right? Because every time I cook a dish, right, as I'm cooking dishes, shouldn't you be using up the soy sauce? So it should be getting smaller. See what I'm saying? I was supposed to go backwards. So it was supposed to be like 46.6, really, right, if I did it correctly. But again, the other on your tests or your quizzes or version 2, version 1, whatever you're working on, it should be okay. It will make sense. This one, I flipped it. Okay, that's my bad. Okay, number 8. Which graph is represented by the function? So we just got to match it again. So let's start with the beginning. This thing starts at plus 9 on the y. That looks like it's 9. That looks like it's 9. Okay, that looks like it's 10, but again, I could be off. Okay, maybe that's 9. So they're all roughly the same. So that doesn't help. So the next thing that's going to help me is the negative 1/3. So if I see negative 1/3 as my slope or my rate, how does that look like? Well, if it's a negative, I need to go down. So it can't be A. It could be B, it can't be C, and it could be D. So now how do I figure out which one it is? Well, my job is to find 2 lattice points that's going to help me out. So in this case, if I look at these two, they're really close. I went 3 and 1. Remember, M is rise over run. So this one is negative 3 over 1. And if I do this one, it's pretty close. It's 1 and 3. So now it's rise over run. Oh, no, that's not the one I want. It's this one. Right here and right there. It's roughly 3 for sure, and that's 1 right there. So rise over run, I went down 1 and over 3. So that's the one I care about because it is negative 1/3. So my answer should be D. Okay. Number 9, choose all ordered pairs that are on the line. So we just did this one earlier. Let me get my awesome calculator back up. Okay, so I'm going to set this up right here. So there's negative fraction 1/4 times my input or my x plus 2. So again, there's my x and my y. So y equals negative 1/4 parentheses plus 2. So in that parentheses, I'm going to plug in all my x's. That's my input. And I'm going to check if I get the y as an output. So that's what the calculator is for. So y equals negative 1/4 times 16 plus 2, for example. So let's put it in my calculator, put a 16, and I got negative 2. Is that 6? No. So that can't be it. So let's delete the 16. Now let's put a negative 8. And negative 8 gave me a positive 4, so it can't be that one. It's a negative 4. So delete that one. And let's put in a 4 now. So let's plug in 4. And that gave me 1. Yes, that one is true. Now let's think about it, assuming I did this correctly as a teacher. If it's a choose all, you're going to pick 2 or 3 options, right? If you pick one, they should have made it multiple choice. And I'm going to be honest with you, it's rare, and I mean super ridiculously rare to pick everything. So it's somewhere in the middle. So in this case, 2 or 3. And if I already went through this and only one so far has worked out, most likely the last one should work out, right? Because I only have one so far. Let's see if I did this correctly as a teacher to validate what I said. So yeah, so if I plug in 20, I got -3, so that one is also correct. And again, I ended up picking 2 or 3 as my options. Okay, number 10. Look at the linear function. Now they want you to write the equation. And they told you how to write it. So you have to copy the structure exactly the same. Okay? So let's look at what we're doing. Just like we have been, the B is on your Y. That's your Y-axis. So that means that my B is -4. What's your M? Your M is rise over run. So let's see, if I do rise over run, they told me to do these 2 points apparently. So I got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. And notice I am counting the boxes, not the lines. Okay? Because if some of you guys who count the lines, you'd be like, oh, that's 7. No, it's boxes. All right, so be careful. So in this case, my M is rise over run, which equals 6 over 8. Now here's the kicker. You need to simplify. And usually when you're doing that with the slope, you pick the points that are closest together. So if I had picked this one, that would have given me 3 over 4. So if I write this neatly, I'm going to get Y equals my M, which is 3 over 4, X minus 4. So that's my equation for that function right there. All right, which of the following table belongs to the function y equals 4x minus 5? So this one is very similar because remember, all of these are just points. And they're points like that, right? So haven't we done something very similar? That is basically this question. Choose all the ordered pairs that are on that line. The thing that is neat here is that you just can plug it in and see if it works out, but that's a lot of points to check. Okay, so is there an easier way to do this? Well, one way to eliminate it right away is to understand y equals mx plus b, right? So remember that b is when x equals 0. That is your y-intercept. So when x equals 0, I got -11. It's supposed to be -5. So that is wrong. Does this one have a 0? No. Does this one have a 0? Yes. Do I get -5? Yes. Does this one have a 0? No. So I don't know. So right now, for sure, it's not A, but it could be B, C, or D. Now, just because C has it doesn't mean it's correct, but it's a good starting point. So what do we do now? Well, let's just plug in our equation. So what do I mean by that? I got y equals 4x minus 5, or y equals 4 parentheses minus 5. Let's bust out our fancy calculator here. And you can see right what we did earlier, so let's clear that. So I have 4 parentheses minus 5. Now remember, these are my x and my y coordinates, so I just have to check to see if they work out. So if I plug in 13 right here for my input, so there's 13, did I get 47? Yes. Let's try 5 to make sure. There's 5. Did I get 15? Yes. If I plug in 8, did I get 27? Yes, yes. So I assume the other ones are correct, and in this case, that one is my answer. Okay, this one, could you have figured out 0, by the way? Some of you guys are clever. You're like, yeah, look, 30, 25, 20, 15, 10, 5, 0. So you're subtracting 5 every time. Well, right here, guess what you're subtracting? Minus 4, minus 4, minus 4, minus 4, minus 4. This one would have been 0. And what do we want? We want it a negative 5. So that one wouldn't have been true. So then it would have been a 50-50. And again, this one is totally random. So who even knows? Okay. So yeah. Okay. We got lucky with letter C because it already had the B right there. Okay. Next one. So this was what? I don't even know. A couple sections, okay, in algebra. So which of the following relationships shows a function? And let me rephrase this to you. This is a difficult one for a lot of us. A function, what does it mean? Every input has only one output. Okay? So think about it this way. Your input is your X, your output is your Y. So it's a really difficult concept to understand unless, like I said, you've been paying a lot of attention in class, which I hope you have. Okay, I'm trying to relate it to like life. All right, so let's use money because you guys love money. So let's say, for example, you go to the store, right, and you want to go buy a bag of chips, right? So your bag of chips is your input. How many bags of chips do you want? 1. How much should it cost? I don't know, like, what is it, $2.89, $2.50, whatever, okay? So if you buy one bag of chips, let's say at Stater Brothers, it should be $2.50. If you buy one bag of chips at Food for Less, it should, guess what, still be $2.50. If you buy one bag of chips at Vons or Pavilions or Save Mart or H Mart or wherever, you're expecting to pay the same amount, right? So when you buy one bag and it's not, then it's not going to create a function. Okay, you can only have one output because in the way I want you to think, it doesn't make sense for me to plug in one and get 2 different answers or get 2 different prices. Okay, hopefully it's a little bit clear. So let's use this as an example. Okay, so when you have a graph, it's a lot easier. So this is my input, that's my output. So let's say I had X is 5. Well, guess what? I have this, 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 and that. I have 4 outputs. So that one, yeah, no, that is not a function. And if you remember in class, what we do, we call it the vertical line test, right? It can only cross once. So if it crosses more than once, it is not a function. That was your shortcut in class. What about this one? Every input can only have one output. So in other words, all your X's must be different. Now, if you're totally lost, you can always graph this. So -1, 2, boom, right there. -3, 4, boom, right there. -5, 6, 1, 2, 3, 4, 5, 6. Boom. Then I got 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 9 and 10. 11 and 12. So if I do the vertical line test, did I have 2 on the same line? No. So this one is a function. The shortcut is, are all your X's different? So if you look at them on the graph, if all your X's are different, then I don't care what the output is, it's going to be 1 point on the X line. Because remember, this is X equals -1. That's the vertical line. X equals -3. That's the vertical line. Okay. So same thing right here. I got 1, 3, 5, and 7. So that one works out. Okay, and the last one, I got y equals 0.35x plus 1.5. You're like, what the heck? But if I graph this, remember, what do I start? There's my b at 1.5. What is my slope? 0.35, so it goes this way, and it's a straight line. So if I do a vertical line test, it only crosses 1 time, so this one is awesome. So yeah, these are tricky, okay? I always recommend graphing if you can, graphing the points, okay? Because then you get to see if it's, the vertical line test is always easier for you guys, but you have to have a graph. So if you don't have a graph, you can always make one, right? It was a little, not too perfect, but you can make sense of it, right? Like you can see right there for the second checkbox. All right, moving on. So here's another one. Enter the equation in the form of y equals mx plus b. Remember what we said? That is when x equals 0, because it is your y-intercept. There's x equals 0. That means that's your b. So that makes my life easier. Now what's the slope? So my slope is this change, the change in y, over the change in x. So from 0 to 3, it was plus 3. From 3 to 18, it was plus 15. So again, m is change in y over change in x, which is a fancy way of just saying y2 minus y1 over x2 minus x1. So if you subtract the y's, what did you get? 18 minus 3 equals 15. So 18 minus 3 equals 15. For my x's, how did you get that? You got 3 minus 0 equals 3. So 3 minus 0 equals 3. So when I said y over x, well, there's my y over x, or my change. So I get 15 over 3, which is just 5. So now that I got my numbers, I can say y equals 5x plus 3. All right, next one. Let's see. Vanessa runs a clothing store where she sells custom shirts. For each order, she determines the total price in dollars based on the total number of shirts ordered. She uses a graph below. Okay, so let's just see what they want. So is it less than 8, equal to 8, or greater than 8? So the number of shirts a customer can get for $100. So what do I care about here? I care about $100. So there's $100. How many shirts can I get? I can get 20 shirts. So the number of shirts, well, I can get 20. I can get 25, 30. So between 20 and 35. Yeah. Oh, see? Less than 8 equals. So that's 8, 8, 8. Okay. Or should it have been 5, 5, 5? I don't know. I probably forgot to erase the numbers here from my previous version. So let's see. This probably should have been 5, 5, 5. I don't know. Okay, so let's say, I think this should have been 5, 5, and 5. Either way, it is greater than 5. Let's check the next one. The cost in dollars to get a single shirt. So let's think about a single shirt is one shirt. So how much is one shirt? Well, one shirt should be right there, but you're like, I don't know what that is, but I know that 5 shirts gets me 25. 10 shirts gets me 50. So these are the same rate because they're on the same line. So if I get 5 for 25, 25 divided by 5 equals 5. So one shirt should equal $5. Okay. The average cost per shirt in dollars when a customer orders 25 shirts. So where's 25 shirts? 25 shirts is right there. How much did I pay? I paid 100. We already did that earlier. So 25 shirts equals 100. So what's the average cost? What is 100 divided by 25? Calculator time. Some of you guys already know it, but hey, I'm going to just triple check. Okay, I have the technology. I might as well use it. 100 divided by 25, and that equals 4. So if it's 4, it is less than 5. And finally, the average cost for shirts in dollars when the customer orders 40 shirts. So 40 shirts going all the way up to here, which is $250. So in other words, $250 divided by 40. So 250 divided by 40, and that equals 6.25. So that is more than 5. Okay. So not that horrible. I just had to fix that and make sure it was in fact a 5. So now, I know you can't see me, but I have my computer open with the actual test here, so I got to change it to fix it while I'm currently doing this. Okay, last question, and it's a chill one. Look at the function, write the equation. So I don't know how many times we've done this. So B is right there. So what is that? -4, -6. It's in the middle. That's -5. That's pretty easy. Then they gave us 2 points. They gave us these to find the slope of rise over run. But remember, I told you if you want to find the simplified version, you got to make the smallest triangle possible. So let's find all the lattice points. And if you forgot, lattice points are like the perfect points like these. Okay, the ones that are right on, like I say, the crosshairs, right? So there's one lattice point, there's another lattice point, there's another lattice point, another one, another one. So when I say the closest, it doesn't matter which one. So this one, and then the next one is right there. So that gives me 3/2. So then I get y equals 3/2. That's my slope. X minus 5. If you had done the other one, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you would have gotten 12/8. And then technically that's correct, but remember, it's as annoying as it's always going to be in math. Whenever you hit a fraction, you have to simplify. Okay, that's where your teacher always takes away a point or half a point or whatever. Okay, so how do I simplify 12/8? And you're like, well, what goes into it? I'm going to show you how I would do it on my calculator. So let's see if this one makes it easy. 12 divided by 8 is 1.5. So I could have said y equals 1.5x minus 5, and that would have been totally correct. And then some of you guys are like, okay, well, that's 1.5. Well, if I do 1.5, well, that's just 3/2. Because 3 divided by 2 is $1.50. You get it? 1.5. So it's a bunch of ways you could do this. Okay, what makes this different, just a heads up. I know it's the very end already, and if you're still listening. This is, as I told you, this is the California State Exam version. Okay, see, grade 7 through 8, grade 8, scientific. You guys, if you're used to the normal Desmos, what's different is you can turn it into a fraction. When you do the test, you don't have that option. You have to figure that out yourself. Okay, there's no fraction button here, so you can't convert it. Okay, so just trying to show you different ways to think about it. Okay, all right. So the other way, just in case, I know I should have been done, but it's okay. Okay, little mini lesson here. They're both even. Divide by 2, divide by 2. That gives me 6/4. They're both even numbers, so I can cut them in half. And I get 3/2, and then I'm done. Okay. And some of you guys are like, yeah, divide both by 4. Okay, perfect. Good job. You understand greatest common factor. Good job. All right. That's it. I'm done. Okay. Just see you next time. All right.